Welcome to my project. My topic is Kafka for stream processing. So to start, I'll introduce the problem at hand. So there's three general issues that people face when working with large amounts of data. One is accessing that data, which nowadays isn't really so much an issue. But once we access that data, now we have to sort through the data to separate the signal from the noise. And we need to be able to store this data to be able to process it for later use. So my problem use case is police dispatch call logs. Police precincts get calls every few minutes, but have a limited number of resources. So, which means that they need to quickly be able to sort through urgent calls from non-urgent calls so that they can effectively address communities' needs in a timely manner. And after they decide which data is important and which data is not, they need to be able to store this data so they can do an analysis later on. So the data I used is from the Rockford Police Department, 72-hour call for service dispatch logs. And so on the site, they have available the data 72 hours, and it's updated on a continuous basis, so there's always new updated 72-hour data. So every day for the past 12 days, I was downloading this data to create a larger sample file. This is a sample of the data. So this is actually the website that I went to get the data. And then this is some of the streaming data. And to download it, I just clicked Go to Resource, and it downloaded this CSV for me. So to address my problem, I'm using an integration of three technologies. The first one is Kafka, which I'm using to stream the data to the Kafka server. And in my Kafka server, I created 3 topics for the data to be directed to. And the data was directed to one of the 3 topics based off logic that I will go through a little bit later in the presentation. So I also use Spark Streaming to receive that data from Kafka and then send that data to Cassandra. And Spark Streaming was needed to process the data to map it in a way that Cassandra could read it. And then I used Cassandra to actually store the data for later use and analysis. I created 2 tables for 2 of the different topics in the Kafka server. So below here, you can see the technology that I used in the versions. I used a Windows 10 computer with a 64-bit processor, and I was running a CentOS VMware virtual machine. So then I used Python 2.7, Kafka version 11, and Cassandra version 2.2, and Spark version 2.2. So this is an example of the technology architecture that I utilized. So I had data incoming from 72-hour log files. This data was then sent to one of 3 Kafka servers, as I mentioned before, based off keywords in the log file. So here we have 3 different topics. We have an urgent topic, an other topic, and a traffic topic. So then that data gets pulled into Spark Streaming server via a consumer application, and then Spark processes the data into a format that Cassandra can use, and then it sends the data to the Cassandra NoSQL database. So my database actually is 2 tables. So once the log files come in, this urgent topic is being pulled by a Spark consumer, processing it, and then sending it to this urgent call table. Likewise, this traffic topic is being accessed by the Spark streaming server as well, a separate consumer program, and is sending the data into the traffic call table. So to get my demo started, I started my Kafka server. On this side you see the Zookeeper server, and on this side you see the Kafka server, and you can see that these are both running. Both need to be up and running for the program to work correctly. And then I also started my Cassandra server. Here I had to create a new user called Hadoop, and then I went into Hadoop into where my Cassandra was stored, and I ran the Cassandra -f command to get Cassandra up and running. So for my demonstration, I actually created a separate production environment. I tested all my code onto a test environment where I had test topics and test databases, and then created my non-test topics. So my non-test topics are, as we saw before, are urgent, general, and traffic. When I was testing all these topics had _test so that I can play with the data without putting too much data into each topic. So here we can see that I'm creating, in this image, creating the 3 different topics, and they're successfully created. So here I am creating my Cassandra databases. Again, I had a test environment and a production environment. In my production environment, my tables were called urgent _ calls and traffic _ calls. The idea of this is that I'm playing with 2 of those 3 topics. And as you can see in the image below, I created these 2 tables, and we have traffic and calls. Logs test was the table that I used in my testing environment. So this is the Kafka producer code. I am bringing in the Kafka producer and then creating a loop to simulate streaming data. This loop processes every 1 minute. So it would be kind of similar to how data would be coming in. So here we can see the logic that I used to direct the messages to one of the 3 topics. So the messages going into my urgent topic are going to be robbery, burglary, suspicious, theft, weapon, or criminal. And if any of these words are in the description of the call log will go to my urgent topic. Then I also have a traffic topic, where if traffic is in any of the descriptions, that data will go to traffic. Anything else I'm just setting to general as a bucket. So in this use case, we want to know these urgent calls and we want to know traffic calls, because these are the 2 most frequent, either most severe or most frequent calls that come in to the precinct. So then, as I went through before, this was the logic for my log files and the directing of the data. So again, burglary, robbery, suspicious, theft, weapon, criminal were my keywords for the urgent topic. Traffic was my keyword for the traffic topic, and everything else went to general. So now I'm going to go through my Kafka consumer code. It's not a very complex code. It doesn't do too much processing and addition or subtraction or calculations. But it does get the data into our Cassandra server. So here we have our variables, and as you can see, we have our streaming context and our Spark context, our broker variable, and our Kafka utility variable. Now, Kafka utilities was a jar connection file that was downloaded from the Maven website, and that was needed to be able to connect Kafka to Spark. And then here I'm just mapping to get the data, encoding the data as strings, and then just making a dictionary of the data that I want to put into my Cassandra. And that data is call ID, address, city, date, district, time, and type. And then we use a .save to Cassandra command with the name of the database and the name of the table to send the data from Spark to Cassandra. Now, for Cassandra to work correctly, you do need to put a command that tells the computer to go to the internet and download a file that it needs to have that connection tool. So here is the customer files in action. On this side, you can see that this is the one that is reading from the urgent topic and sending to the urgent call database, and this one is reading from the traffic topic and sending to the traffic calls database. And then this is our producer file in action. To make sure the data was streaming correctly, I had the data printed to the screen every time Spark took data from Kafka and sent it to the database. So to mimic streaming data, I had one line of the data pushed into Kafka every second. And then here we can see that our consumer application did push our data to Cassandra. This is our urgent calls database, and here we could see all of our urgent calls. This is our traffic calls database, and we could see all of the traffic calls. So my program was able to take one big data, split it up into smaller pieces of data through our Kafka topics, and then take the data from the topics and put it into 2 different databases that can then be used to connect to and get the data. So then overall, pros of the software is that the architecture allows for flexibility as business needs change and grow, and users can get just the relevant data that they need, and data is stored in an accessible database. The hardships were Python API could be hard to use because it's mostly reliant on Spark and Java, or mostly reliant on Java and Scala. And then Spark connections to other software can be a little bit complicated to build. And then down here we just have an image of a time series of our urgent data. So this was a fun project to work on. It was fun to integrate all 3 softwares, and I hope you enjoyed it.